welcome to the second day of CYSAT. This morning we will start with the presentation from Gaurav Lanjekar. Gaurav is co-founder and CTO of LeanSpace, where he shapes the technology strategy. He's an expert in software and cloud technologies and has been designing and leading teams to build large-scale security as a service and cloud applications for the past 15 years. Gaurav, the floor is yours. Thank you.
So good morning, everyone. So I think first of all, thank you for coming up and waking up so early. I think like 9 a.m. presentation should be banned. So thank you again. So my name is Gaurav. I'm co-founder and CTO for LeanSpace. And today basically we're going to talk about securing space system with encryption and how do you actually go about it, right? So who are we? So basically, we founded LeanSpace around 3 years ago. We're based in Strasbourg. We are around 40 people now. It's a good mix of space and software people. We have a variety of customers, and with our platform, we are able to solve quite a lot of different use cases. So basically, from OTVs to debris removal missions, EO missions. We have constellations and so on. How do we exactly do this, right? So basically what we have built is something called as a cloud platform, right? It's a scalable scalable space platform as a service, right? The concept is pretty simple. What we have done is we have gone through a variety of different space missions, identified all the common services that occur in every space mission, like telemetry decoding, command sending, planning your passes, defining your activities, doing orbit propagations, and so on. And we've basically taken this out into an 80% scalable space platform, right? So this allows you to basically not start from zero when you're building your own ground segment, but start from this 80% solid base and then basically build only your custom solutions on top. Right? This is very mission-specific things that you want to build on top, you can go about it. We, of course, abstract away the entire cloud infrastructure for you, so you don't have to worry about it. It all comes out of the box for you. So what are we going to do today, right? So we're going to look at how cloud-based systems look like, so different segments and so on. So just to have a common page that we can talk about. We're going to look at encryption, where and where it is done. And of course, we're not going to just do chit-chat. We're going to actually see a small demo on how you can actually leverage what we have built and how you can actually do an encryption when you're building your own ground segment. All right, so this is the typical data flow for a cloud-enabled space mission. So today, a lot of our customers or even a lot of new space players basically start off with a ground station as a service provider, right? So you start off with a cloud which is provided by the ground station service provider. So this abstracts away all the different antennas, the regions, and you have like one singular API that you can access your data from. Usually, they also have and their own cloud or their own premise where they do the different decryption and encryption logic. This is again what we call it as the perimeter of the operator, right? So here is where you'll have all your secure key generation. This is where you would do the actual encryption and decryption logic. And this is for a reason is to basically avoid keys leaving this particular perimeter. Right, and of course, then there is the mission control cloud where your control systems are placed, right? So this is where you would have all your systems, and of course, once data arrives there, you don't want to be stored at rest without encryption. So of course, there is also encryption at rest. There are a couple of opportunities there. So for example, in the cloud, you could use a key management provided by the cloud itself. But again, this goes against the keys not leaving the operator perimeter. And that's why you could also have options like, okay, I would still be using the key management, which is done on-premise or in the operator's cloud, and then basically proxying that over so that you can use it for the data encryption at rest as well. today we're going to talk about basically these couple of flows. So basic encrypting data on board and then coming it down onto the ground, and then basically the decryption happening there, and how exactly you would go about it. So of course, only encryption is not enough. So encryption assures you confidentiality, but of course, in addition to that, you also need authentication, right? So there are a lot of standards out there which recommend how do you go about both of these techniques. There are different algorithms you can implement to satisfy both of these conditions. There is also recommendations from CCSDS which talk about both of these independently and also together. So you can decide based on your mission what you want to do. So of course, we definitely recommend at least having encryption. So when we talk about encryption, we usually talk about keys, right? And of course, I think most of you would be aware, like there are two different kinds of encryption methods. You have your asymmetric keys or asymmetric encryption, and then you have your symmetric encryption as well. So usually in space-based systems, you have most of the missions use symmetric keys. Why? Because of course, first and foremost, it is less expensive in terms of computation. It is very easy to the algorithms which are implemented are much more memory efficient, and that's why the preferred choice is usually a symmetric encryption. One, let's say, good thing about space missions is you have a secure channel. So when you are actually launching your satellite, you have a physical control of your satellite, and this is where when you provision your keys, you're able to actually put them on board of your satellite and then go from there. Of course, there are protocols and procedures on how do you rotate keys on board, how do you provision newer keys, how do you switch between them, and so on. But with the new hardware coming across and things like this, there are changes to this as well. You are now having asymmetric encryption also being used, and so on. So today, basically, we're going to see an example with symmetric keys, because that is the most common one that is being used. This is the life cycle of the encryption key. So when we talk about encryption, we need to consider like the entire life cycle, how it goes, because security needs to be in place for all these different phases. So it's not only about, okay, when in use, how do you actually use this, but also how do you provision keys? Is there a secure method of actually provisioning these keys? So where do you generate them? Are you using a key management system? Are you using a hardware-based security module? How do you actually go about this? Once the keys are generated, how do you distribute them? So what is the mechanism around that? Usually the general practice is to have multiple keys on board, so that if one of the key is compromised, you are able to switch between different keys. So how do you configure this system to switch between different keys? And of course, the nominal operation, which is to use keys to actually encrypt and decrypt data. And then, of course, you have crisis management. So what happens if my key is compromised? What happen? Do I have a time-based key? So do I use a key only for a few months, and then I have a practice of switching these keys over? So all that part is also part of the life cycle of the encryption keys. And with that, basically, now we'll head on to the actual demo. So what are we going to see? So what we're going to use is a service by LeanSpace, which is called as a root service. So this particular service allows you to model your data flows, all your last mile data flows, or any place where you want to move data around, you want to process this data around. You want to do this in a modular way, in a way that you're able to deploy this on different machines and so on. And you have the possibility to actually monitor these flows, modify these flows safely in production as well. Right? How it works is basically what we call as building blocks. These are connectors and processors. So connectors, of course, allow you to connect to different systems. And then you have processors which process messages going over these different things. Right? So yeah, so basically what you're going to see over here is this particular flow. So we're going to have a connector. So we're going to simulate data being received on a UDP listener, a TCP listener, and then we are going to decrypt the data as it comes along. and we're going to process the CCSDS frames and then send it to another lean space service, which will help you decode this data. Right. So let's see. I'm just going to quickly switch to. Is this visible at the back? If not, I'm just going to zoom in a bit. Okay. So this is how a route looks like. So this is my TM route, so which is responsible for actually decrypting this data, right? I'm going to listen to a TCP port. So this is where I'm assuming the data would come in. I'm going to use a processor that comes out of the box, which is a CYSAT decryption processor. So this is responsible for actually getting the data using a key management system. So we're basically using the Arca OS to use the keys to actually decrypt the material, and then basically moving forward to a CCSDS frame processor. So this one basically simply extracts this one out, and then you have the data being pushed into the lean space stream, right? So to simulate that, what I've also used is how do you say, an encryptor. So to simulate like the actual encryption or what would happen on board. So this is what I've been trying to do is to get a few frames and actually encrypt them again using a CYSAT based encryption processor. So right, so on both sides we are using a key management system. So the keys never leave the perimeter, and basically you are able to encrypt and decrypt data. Right. So for example, I have the KMS running over here, and I have my root also running over here. So basically what I'm going to do is I'm going to pick up a file which I've already encrypted using the other processor that I have shown, and I'm going to simply send this data over. So you can see basically some bytes of data were sent. They arrived at the root. You can see some data which is in an encrypted format. It goes over to the KMS, and basically here you can see like, okay, we are using the decryption methods or the APIs from the KMS. The data is encrypted. It is sent back. It is processed further. So you can see the decrypted message, and then it is decrypted. Once it is decrypted, it is processed further. So the frame is converted into packets, and then it is sent over to the lean space service. So I'm going to go to a different service, and basically I'm going to see the last values as they have arrived. So we can see like, okay, the packet has arrived. I can see the data which is in the packet. So yeah, so this is basically like the entire flow. So we had encrypted packets. We created a route which allowed us to configure it so that we are able to use different decryption methods and then process the data further. Of course, with the flexibility that is available to you, you are able to choose one KMS over the others. We have full flexibility in terms of which KMS you want to use, and you also have the flexibility to use different protocols. So for example, here we are using the CCSDS protocol. We are encrypting the entire frame. Of course, all customers do it differently. There is also a recommendation from CCSDS how to do it. You are able to use a CSP protocol or even a custom protocol to start with your encryption needs. I think this is it for my demo. So yeah, if you have questions.
Thank you very much. Any questions for our speaker? Actually, I have a couple of questions. I understood that this is an application, correct, from where you can, I would say, manage your telecommand, telemetry, and of course, encrypt, decrypt it. And up to now, you have implemented the CCSDS, of course, standards, which indeed are based mainly on symmetric-based encryption and pre-shared symmetric keys, as you explained, which makes sense for the typical institutional missions of the maximum 10th of satellites. What about the new space era where we have hundreds of satellites. Are there any plans of expanding the application to cover these cases?
Right. So again, the way we have designed the lean space platform is exactly keeping this in mind, keeping the scalability in mind. How do you go from 1 to 100? And that's where services like routes, services like streams come into the picture, right? So these allow you to model things in a way that they are modular, they are easily clonable. So for example, in routes, you're able to create like hundreds and thousands of routes. You're able to run them on-premise. Basically, routes is like packaged as a Docker container, so you can take these, you can run it. The entire platform itself runs on the cloud, so it is cloud native. It is built for scale. So and of course, the example processor that you saw was for CCS, yes, but it does not stop there, right? So you're able to, again, you can use the out-of-the-box processors that you can get, or even like we have seen for our customers who implement custom protocols. They're able to simply write their custom processors and implement the encryption and decryption logic there, or even additional data processing steps. So it's quite flexible in terms of what you can plug in, where you can plug in, how do you move around, different flows that you can create, and so on.
Okay, thank you very much. Any question from the audience? Okay, I will follow up then. Now, coming to this, okay, the symmetric part was based on the advanced encryption standard, of course, which is the de facto standard anyway for decades, I would say now. Since you are planning to have this integration for new space applications and the key management is going to change, have you started any kind of experimentation how this will be performed? This will be some typical Diffie-Hellman or something else?
Yeah, so again, we work very closely with our customers and see where they are going with their encryption needs and so on. So we are performing some experiments, like some templates, something that we can provide out of the box for our customers as well. Again, with asymmetric keys as well. So yeah, this is always going on. Yeah.
Okay, thank you very much. No questions?
Okay.
Okay, thank you very much.
Thank you.